Welcome to episode 232 of Build Your House Yourself University by BYHYU. I'm your host and fellow student, Michelle Nelson, and together we'll learn the basics of home design and construction and demystify the building process so we can select the best materials for our projects and build quality dream homes with or without a general contractor. If you're considering building a house with exterior cladding made of stucco and or manufactured stone or thin natural stone veneer, this episode is for you. This week we'll talk about the moisture control challenges that we can run into with stone veneer, manufactured stone, and stucco cladding. Peter Barrett is our guest today. He's the product and marketing manager at Dorken Systems. Dorken specializes in high-performance air and moisture barriers used to protect residential and commercial projects. In our interview, we'll delve into how we can help alleviate the moisture problems that are often seen today with stucco and manufactured stone. Peter's a great teacher, so let's get right into the interview.
Peter, thank you for joining us today. Can you tell us a little bit about Dorken and what you do there?
Thank you for having me today, Michelle. I truly appreciate you inviting me on to your famous podcast. My name is Peter Barrett. I am the product and marketing manager with Dorken Systems Inc. We were formerly known as Casella Dorken. We're now known as Dorken Systems. We are part of a family-held company based in Germany. We've been in existence now for over 125 years, still owned by the same family. So we have a long history in the construction business and a long family interest in staying in the construction business. Mm-hmm. So we've been manufacturing spun bond sheet membranes for use in roofing and walls. Our sheet membranes, we specialize in moisture vapor permeable, yet watertight membranes, and we've been making those since the 60s. Other components that we make are high-density polyethylene or polypropylene dimple sheets for drainage and damp proofing on both residential and commercial structures. We're probably most widely known for our Delta MS foundation protection system, which is used on residential homes. It's a great replacement for spray-on asphaltic membranes. But as you go north, basements are required simply for frost purposes, if for no other reason. I've been involved in the construction business now for really longer than I want to tell you, but it's pushing around 30 years.
Oh, wow.
So I've always been involved in the moisture protection business. I've done waterproofing. I've done commercial and residential building enclosure for air barriers, vapor barriers. I've also done both residential and commercial roofing work. I have a fair good acquaintance with the building enclosure, both residentially and commercially.
Well, what we wanted to talk about today, Peter, was about stucco cladding and some of the failures and challenges that we have with stucco. So let's just get right into it. Why is stucco cladding such a popular material for builders and homeowners these days?
Let me say upfront, stucco is a great cladding. They've been making it for probably 1,000 years or so. And when installed properly, it is very durable. It looks great. So I want to emphasize anything I say today isn't because stucco is a bad cladding. It isn't. It is a great cladding.
Okay.
It also functions very similarly to adhered stone. So any sort of manufactured stone, Dr. Joe Stiebrick will call it lumpy stucco. All of the physical properties that we will discuss on stucco will equally apply to manufactured or adhered stones.
Oh, that's good to know. Okay.
It is a very durable cladding. It's great for anybody who wants either a really modern look because it can look very smooth, very sleek, minimalistic, if that's what you care to do. Or conversely, you can also make your house look like it's straight off the streets of Elizabethan England, if you would like. Mm-hmm. So stucco is extremely versatile and it can make a great looking building. You need to be sure, however, that we distinguish what we're talking about today, which is traditional three-coat stucco, from exterior insulated finishing systems, commonly known as EIFS. So what we're going to talk about today will be traditional three-coat stucco and manufactured stone.
Okay, wonderful. So tell me what separates successful stucco installation from those that are prone to premature failure. Are there any downsides to using stucco in home building?
That's a great question. If I may refer to Dr. Stiebrick again, you can find articles of him where he talks about the coming stucco apocalypse, meaning he expects a lot of failures from inappropriately installed stucco. We see that right now in several major areas across the U.S., through eastern Pennsylvania, in the greater Philadelphia area. It's happening in Florida. It's happening in Texas. Those would be probably the three top areas for problematic stucco installations. The thing that needs to be taken into account when using stucco or manufactured stone, adhered stone, is that they fall into a category of claddings called reservoir claddings. A reservoir cladding is any cladding that will absorb moisture. You can think of it as like a capacitor for water. As water hits it, it will begin to store that moisture. It's not just surface wet. That water moves right into the material. When it becomes soaked, it becomes fully soaked through the cladding. It will hold water. So just like a capacitor, it will take on water and it will lose water. And that's one of the most important things to realize about stucco. Now, the water doesn't hurt the stucco itself. In the same way we can say, in the strictest sense, moisture doesn't hurt concrete. What the moisture hurts is all of the stuff around that. The biggest problem with any cladding, but in particular with stucco in the way it's been traditionally installed, is essentially that water gets in, makes moisture-sensitive building components wet, and the water can't get out and can't dry out.
I see. So, yeah, we've learned on the podcast that moisture is one of the biggest enemies of any sort of construction, but particularly with stick-built wood framing construction. So, yeah, I could see how stucco could be problematic in that sense. What are today's builders doing or utilizing in terms of materials and design to protect stucco claddings from rainwater and other elements?
Let me take a step back here first and say that I agree with whomsoever said that water is one of the major issues in structural degradation in any building, be it commercial or residential. Mm-hmm. It's by far the thing that degrades buildings most. And one of the things that you can often hear people say is, well, I had stucco in my grandfather's house and it lasted 100 years. Mm-hmm. Or I've never had any problem on this 70-year-old building. Why am I suddenly having problems now? And the root of the issue really comes because we've changed the way we build. And we've changed the way we build on several significant fronts. One is, as you just mentioned, obviously we build a lot with lumber.
Yes.
Stick building. That's if you can afford it these days. But wood in and of itself can be a moisture-sensitive material. It can handle a certain amount of moisture, but it has limits. A material like OSB, it doesn't absorb and disperse moisture. It gets wet in a single spot. What I'm really trying to say is that we are now using much more moisture-sensitive materials than we used to. So if you combine that with the fact that we've added insulation to our wall structures that didn't used to be there, so that 100-year-old home with stucco on it that lasted very well probably had almost no insulation in it, which means as you heat your house or as the sun hits it, it just dried right through.
That makes sense.
You are essentially heating your house to help dry out the walls. Mm-hmm. We added more insulation. We changed dew points in the wall. We added vapor barriers. All of that to say that we've really changed the way we build, so we've also changed the way buildings live, the way buildings manage moisture. One thing that we do know is that walls get wet. ASHRAE says approximately 2% of all the water that hits the wall will get through the cladding to the other side of it. A further 2% will get all the way through the wall to the weather-resistant barrier. Depending on how you have your weather-resistant barrier installed, it may get through that to the inner wall system. Basically, what I'm saying is walls get wet.
Yes.
And we know that. If you add to that anything wet enough, warm enough, long enough is guaranteed to go moldy, as sure as death and taxes. The mold will find suitable growing areas, and if it stays suitable, if you're a little mold spore, then they will continue to grow and continue to reproduce, and they can do that at quite an alarming rate. So those are the issues that the builders have to deal with. People are expecting higher performance houses now.
Yeah.
They expect a reasonably well-insulated house. They don't expect to spend excessive amounts either heating or cooling it, and they don't expect drafts. In the past, as I said, our old houses were very leaky. They didn't have good air barriers, so we had warm air passing through, carrying moisture, drying it out. If it added moisture, then that moisture would be able to dry out. Now we build with air barriers. Many people will ask, well, can my house be too tight? And the simple answer to that is no, your house may never be too tight. Do you need air exchanges? Yes, you do. That is an HVAC issue. You want to be able to control the air going in and out of your building. You want to know how many fresh air exchanges you're getting, and you want those to go through the designated spots, because air moving through random spots in your wall will lead to moisture issues. And in fact, I have had people say to me, well, I think my building needs to breeze, therefore it should be leaky. The thing to realize is that some of that air that passes in an uncontrolled fashion through the wall may not be all that fresh, because it blows through your wall. It can pick up mouse droppings, it can pick up mold, it can pick up dust. So while you would be getting an air exchange, it may not be all that fresh.
Yes.
So all that being said leads us to the idea that walls are much more able to get wet, either from the interior forces, where you're living, generating moisture every day, when you bath, when you do dishes, when you cook, and when you breathe, and we can get moisture coming in from the outside. So that could be through rain, snow, landscaping, water. So as an example, if you happen to have that sprinkler head pointed at the house, that is also a source of moisture. So knowing that things get wet, we want to be able to make it dry. One of the most effective ways to do that is to add a rain screen system to the wall. There are a bunch of different ways to do something that could be called a rain screen. Just the term rain screen itself can get you hours of debate on whether it's being used correctly, but there is an association that's just been formed called the Rain Screen Association in North America, also known as RAINA. I think you can find it online at rainscreen.org, which is an industry association of installers, manufacturers, commercial and residential, to bring some consistency to the rain screen industry. If any of your listeners are interested in that, I encourage people to go to that site and potentially become involved in the organization. It's fairly young, but I think it's an important organization. So what are we trying to do to the wall in order to add drying? Many building codes right now already require some form of drainage behind stucco. The building code will say that you need 2 layers of a 60-minute equivalent WRB or building wrap of some sort. Many times this goes on in the form of number 15 felt. The reason for the 2 layers prior to the lath is it actually doesn't take very much space in order to have drainage. You can get drainage out of a space as thin as a millimeter or 2. And that's what you're really getting when you put on the 2 layers. The idea is that that space will give drainage. But if you add a larger space, you will get drainage as well, but then you can add the component of ventilation. Ventilation is very important because it adds drying energy. Think of your own dryer, for example. If you throw clothes in but don't turn it on, your clothes won't dry.
They won't dry.
Right. If you turn it on and add some air to it, it dries more quickly. If you add air and heat, they dry even more quickly. And it's very similar in the wall. When you add a space to the wall, it will give you a certain percentage of drainage. So you may see somebody claim 80% drainage, or you may see somebody claim 95% drainage. All of that is good. We want bulk water to drain out. The issue in the wall, however, is not about the water that you can drain out. It's the water that stays behind.
Right. That's what causes the damage.
Correct. And reservoir claddings like stucco will allow moisture, well, first of all, sit in them, but it will also allow them to pass right through. Now, we have put a water-resistant barrier on the wall. We have to by code, and that may be your air barrier as well. But it's very important to remember, anything that is moisture vapor permeable is moisture vapor permeable both ways, meaning that it can allow moisture to dry from the inside out, but it will also allow moisture to move from the outside in. There is no way to make a membrane of any sort that acts as your air barrier and water-resistant barrier that is moisture vapor permeable only one way. None of these are little one-way valves on the thing. This will be true whether you use a membrane that's moisture vapor permeable or whether you use a fluid applied that's moisture vapor permeable. Any of those will be moisture vapor permeable both ways. Well, why do we care? Stucco has been traditionally directly applied to these either single layers or now usually a double layer building paper. And then they put on their lath, whether it's metal or fiberglass. Then they apply their scratch coat. Then they apply their brown coat. Then they apply their finish coat. That's the traditional way of installing stucco directly to the substrate. Very normal. As I said, you are getting your drainage, but you're not getting your drying. Again, why do we care? Well, I've mentioned a bunch of times about reservoir cladding. So now think of this wall. You've had a good rainstorm and your stucco has absorbed a lot of moisture. Now the sun hits it. If you look at that wall on the outside, it will look like it's drying. It will surface dry to the outside. But now basic physics comes into play. As the sun heats that wall, all of that area now becomes an area of high moisture vapor pressure, which is normal. You add heat energy, as in the sun, the moisture vapor pressure will increase. But as you go farther in to that wall, it's cooler and it's wetter. One thing we know is that moisture vapor moves from areas of high concentration or high vapor pressure to areas of low concentration or low moisture vapor pressure. Since we have the sun creating an area of high moisture vapor pressure to the exterior, none of that moisture can now dry to the outside anymore because it won't go from low pressure through high pressure. It's going to start moving inwards.
Inside. Mm-hmm.
And it moves inwards because that area is cooler and of lower moisture vapor pressure. So again, that's basic physics. My memory says that's Boyle's law, but I stand to be corrected.
And I can't correct you.
As that moisture moves inward, it will meet the weather-resistant barrier. What did I just say about weather-resistant barriers? I said that they're moisture vapor permeable both ways,
Mm-hmm.
and there's no way to stop that. So that sun begins driving moisture into the wall. That's called solar-driven moisture. So once it passes through the WRB, now we have moisture coming in contact with our moisture-sensitive substrates, whether it's plywood or whether it's OSB, whatever it may be. So those substrates get wet. We still have the same issue. They cannot dry outward.
So what do we do, Peter, to sort of alleviate or at least decrease the risk of that happening?
One of the first things that we want to do is add an airspace. We want it large enough to drain, but we also want large enough for air movement. Typically, you will ventilate this bottom and top. That will allow for air movement driven by a couple forces. One is buoyancy of air. So that sun hitting the wall makes it warm. Warm air rises. That warm air carrying moisture from that cavity moves upwards and outwards through the top vent, while cooler, drier air comes in the bottom vent. So in a sense, we now have an active dryer for our wall. It will moderate the humidity within that airspace. It actually creates a space for that wall to be able to dry outwards. And if you're using a reasonably high perm air barrier and water resistive barrier, that will increase the rate at which your wall can dry. Mm-hmm. And it's really all about making something dry as quickly as possible. As I said earlier, the longer it stays wet, the better the odds are that it will go moldy. In order to prevent the solar-driven moisture, in our case, we make a high-density polyethylene dimple membrane that creates about a 3/8 inch space, 10.5 millimeters, that you ventilate top and bottom. That gives you in excess of 95% liquid water or bulk water drainage out the bottom, but also gives you excellent air movement. So that allows moisture from the inside of the wall to move into the space and out, and it prevents the moisture from the outside being driven in. So that will give you a full block from solar-driven moisture. There are entangled meshes out there, which do a great job of creating the space for drainage, and they will often add ventilation if they're detailed correctly. What an entangled mesh doesn't do is resist solar-driven moisture. That's really what a builder can do. This will add a lot of durability and sustainability to any wall containing moisture-sensitive materials by adding the ventilation, adding the drainage, blocking solar-driven moisture.
Well, great. I read about your rain screens many moons ago, and it's something that we've decided to use on our project, the Ultimate Idea House. We're going to use the product called the Delta Dry and Lath. And what's great about it, and I told my audience about this before, it's a 2-in-1 solution, and it features both a rain screen and the fiberglass lath on which they will apply the stucco or the stone veneer. So tell us a little bit more about that Delta Dry and Lath product. What makes this better for builders than, say, using a separate rain screen and then a separate lath?
You raise a good point about the two separate products. We actually manufacture Delta Dry and have done for about 15 years with that mesh. We call it Delta Dry and Lath. And we also make it without that mesh for different claddings or different installation methods. The actual performance part of it really is the Delta Dry. As I described earlier, it's a 10.5 millimeter or about a 3/8 inch dimple. You have the cup side facing out. When you put it on the wall, you nail it, but only enough nails to hold it up because the nails for the cladding and the mesh will add most of the holding power. You can use all of the Delta Dry series with standard stucco starter strips and standard stucco details. So there's really isn't doing anything to the stucco installation. They'll install it exactly the same way. It'll just bring it out about 10.5 millimeters. We began making the product with mesh. It's actually a fiberglass mesh, and it's designed to resist the alkalinity of the cementitious coatings that you put on it. You can't just use any mesh because it can degrade within the wall due to the alkalinity of the concrete you put on it. The essential idea is to give a firm substrate for people to apply either manufactured stone, adhered stone, or stucco, but get this all on by minimizing fasteners and by saving time. So you are getting your rain screen and your mesh all in one step. Let me contrast to the way you might do it without it. Of course, you always have to put up some form of a water-resistant barrier. The code requires a minimum 60-minute equivalent water-resistant barrier. We have those. We have those as Delta Vent S, which is our mechanically attached version. We have it as Delta Vent SA. We have it as Delta Stratus SA. All of those are 60-minute equivalent papers. There's actually a bunch of them out there. You always have to put that on first. We are not eliminating that step. Then in a normal application, the rain screen would go on. So let's say you fasten up your Delta Dry. So you go around the house, you put that on. Then you've got to come by and then nail on whatever mesh that you're using. So not only have you used nails to put up the Delta Dry, then you also have to put up nails to put the mesh on. So you've got two issues there. One is, well, there's a cost of nails and a cost of labor, but you also have more penetrations of your enclosure. So if you can put this on in a single step, reducing the fasteners that go through the enclosure, we're reducing the number of fasteners that you have to buy and install, and we're eliminating at least one more trip around the building or whatever area that you're covering with stucco. It adds a lot of speed, it adds a lot of ease, and just to be clear, it meets all of the code requirements.
Okay, that's why I love that product. It's a time saver and it's a money saver, and it protects your home at a much greater level than not having it, particularly if you live in a rainy, humid climate like I do. So our last question for today, Peter, is in context of above grade moisture control. What are one or two things you'd like to see more homeowners and architects be mindful of?
I think I've really been touching that the whole way along, and that's to remind them how important moisture control is in the wall. I would like to see people flash windows more carefully. Certainly, I live in Ontario, and if you drive around to many building subdivisions, you can see windows either not flashed or poorly flashed. So that would be one great source of moisture that they ought to be a little more careful with. I personally love the idea of adding this drying ability to the wall because it adds so much reserve to the wall. If moisture gets in, if somebody doesn't install the weather-resistant barrier quite right, we have all of that space for drainage, and we have all of that space to help get the wall dry again. One thing to remember is that should liquid water get into that 10 millimeter space, it's automatically going to drain out because there's no longer any force pushing it through the wall. This is what the air gap does, is it removes any hydrostatic pressure, any force from the water, and then gives it a space to drain out. Some people will call this pressure equalization. Residentially, I don't get that concerned about that concept, but it's still there. So I would really like to see builders and architects grasp the risk of using reservoir cladding.
Well, this has been wonderful. Thank you so much for all of your advice and for your insight. If my listeners wanted to get more information or see the products that Dorken offers, where can they go?
I'm going to recommend a couple places. First of all, obviously, dorken.com, where you can see all of our products. But once you're on the homepage, you can also click on the page entitled Delta Academy. We have many, many videos there. Yes, some of them are oriented around our product, but there's also a whole bunch there that are straight educational material. So you can see some well-known luminaries of the building science business explaining many building science concepts. You can see, for example, Dr. Joe Stebrick discussing the rain screen principles in walls and a bunch of other things in our Cup of Joe series. I actually have a brand new one up there with Dr. John Straub now explaining pretty much what we just talked about, but he's discussing the rain screen and drainage and solar-driven moistures in the wall. So we have a whole bunch of educational material there beyond just straight product promotion videos, which of course we do have that also. I also recommend either RDH Building Science website, but certainly Dr. Stebrick's website, buildingscience.com as well, for people who simply want to further their education.
Well, that's so helpful. Thank you for joining us, Peter.
Michelle, it was an absolute pleasure. I'm always happy to be able to talk about rain screens and moisture management.
Well, we loved it. Thank you so much.
That's it for this week. I hope you learned as much as I did, and I hope you'll join me again next time for another episode of Build Your House Yourself University by BYHYU. Please remember that the purpose of this podcast is simply to educate and inform. It's not a substitute for professional advice. The information that you hear is based only on the opinions, research, and experiences of my guests and myself. That information might be incomplete, it's subject to change, and it may not apply to your project. In addition, building codes and requirements vary from region to region, so always consult a professional about specific recommendations for your home.